Okay, so hi and welcome. Can you hear me? So can you hear me properly?
Yes, sir.
But I cannot hear anyone.
Yes, sir. Your voice is clear.
Okay. Okay, so just we are waiting 1 or 2 minutes for joining all of the other participants, then we'll start. Okay, so now we'll start our today's session. So basically today I try to discuss about the some advanced concept on Google Earth Engine for remote sensing analysis. So how we can easily get the different types of satellite images and work for the different types of remote sensing analysis using Google Earth Engine platform. I will try to describe for today's session. So let's go. Okay, so now can you see my screen? It is visible. Okay, so let's go. So hi and welcome to the 7 days online training program on Google Earth Engine. So basically today is our second days, and mainly today I will try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat and Sentinel images, how we can easily filter and also displaying the satellite images for any specific region. Okay, and then how we can easily use the different types of band combination. Okay, using these images such as true color band combination, false color band combination, or any other types of band combination. How we can easily use. Then we also try to discuss about that how we can easily export the satellite images from Google Earth Engine platform and use this image for the other sources, other geospatial software. And then how we can easily import, filter, reduce, clip, and display the data in Google Earth Engine platform. And how we can easily make the time series chart for NDVI or any other indices, how you can easily make the time series chart. And how can easily export any shape file from the Google Earth Engine platform and calculating any indices from satellite images. Okay, how can easily calculate different types of indices. So let's go about that. So first of all, Earth Engine public data catalog. So basically this it's the Earth Engine public data catalog. In this Earth Engine public data catalog you can find lot of data set, lot of publicly available data set we can easily access in here, such as Landsat, Sentinel, then Moody's, different types of train data set, land cover data set, different types of atmospheric data set we can easily access from here. As well as this data set is the updating daily. Okay. In this artisan public data catalog, here we find out more than 200 public data set, more than 4,000 new images every single day, more than 5 million images, and also get the more than 5 petabytes of data in this Earth Engine public data catalog. And this is the link about the Earth Engine public data catalog. Simply go to this link. You can get all of those data set you can easily access from this link. So it's the Earth Engine public data catalog link. So in this term, I talk about that how we can easily filtering and visualizing the satellite images. Okay. So first of all, when you want to filter the Landsat image or sentinel image, this filtering process is depends on some factor. So filtering process, first of all, it's depend on the region, your specific region. Suppose you want to need this satellite image for the Landsat image, you want to need for the Dhaka city. So region is the one factor for filtering. Another factor is the image specific metadata or image properties. Suppose you need only for this image will be not more than 1% cloud covered. So it's another factor. And third factor is that a specific time period. Suppose I need the image for the dry season, I need the image for the wet season, or I need the image for a specific month, or I need the image for the specific year. So when you want to filter the satellite images, it can be Landsat or Sentinel. Both of time, just follow these three factors. First factor is that your region of interest. Second factor is that a specific image metadata or image properties, filtering the image properties or metadata. And third factor is that a specific time period. Okay, so let's go the practical example for filtering. So I simply open my new code editor and try to show you that how it will be work for the filtering. So first of all, I need to go the Art Engine public data catalog. So for that, if you want, you can simply click on here and you can see browse data catalog. Okay, click on here, it directly open the Art Engine public data catalog from this link. And here you can see the Landsat. Okay, I want to work for the Landsat. So click on the Landsat. So now I can got all of those Landsat image collection for Landsat 9, Landsat 8, Landsat 7, Landsat 5. All of this image collection I can get for the Landsat. You can see Landsat 9, Landsat 8, Landsat 7. Also you can see Landsat 5, okay, Landsat 4, and Landsat 1 to 5. All of this image collection I can easily access from here. Okay, so here you can see the Landsat 9 year of 2021 to present available, Landsat 8 2013 to present, Landsat 7 1992 2021, Landsat 5 1984 to 2012, Landsat 4 1982 from 1993, and Landsat 1 to 5 1972 to 1999. Okay, so this is the time duration for the different Landsat image collection. Okay, so in this time, both all of those images, when you want to filtering or visualize, same approach for the all of those image collection. Okay, so in this time, suppose I choose the Landsat 8 image collection, click on here. So in this time, I also get the some different image. You can see one kind of the surface reflectance imagery, top of atmospheric, raw image. Okay, so in this time, all of those image collection, when you filter, just apply the same approach. There is no differentiate is one other. All of those images, when you want to filter, it will be same approach. So in this time, I show you that suppose top of atmospheric or surface reflectance, anyone, and the same approach. Okay, suppose surface reflectance, I simply choose the surface reflectance and open that. So here I get this image collection and dataset availability date. We can get the dataset from year of 2013 to year of 2023 08 31. This time period we can access the dataset for the Landsat 8. And here I can get the dataset provider. It's the provider is the United USGS. Okay, and Art Engine snippet. So basically it's a unique ID. Okay, it's a unique ID of this dataset. Every dataset has their own unique ID. So in this time, it's called the Art Engine snippet. So basically this Art Engine snippet is the unique ID of this dataset. Okay, so first of all, this dataset I want to import in my code editor. This is my code editor, and this is my dataset for the Landsat 8 surface reflectance imagery. So now how I can import the dataset? So it's very easy. Just simply copy the unique ID or snippet from here. Simply copy and paste on your editor, code editor. Okay, and then give a variable name. Before the variable name, put here the var keyword, and then give the any name. Suppose I put the name is the L8. So in this time, what happened? In this time, this is my full image collection. Okay. And this full image collection is stored in this variable L8. So L8 is now stored the full Lancet image collection for the whole world, for the whole time period, year of 2013 to 2023. All of those images stored in this variable L8. So now let's check how many images in here. How many images in here? I want to count the value. So for that, simply use the print function, and full image collection is stored in this variable L8. So just I simply copy the L8 from here and then print this size. So use the size function. Okay. So now it counting or computing how many images are available in image collection. So now let's check. We can check how many images available for the whole world, for the whole time period, year of 2013 to 2023. So it counting in computing about this result, how many images available for the full image collection.
Sir, why it is size? Why we taken size?
Size function mainly counting the value. Okay. So in this time L8 stored the full image collection, and now from the L8 I want to count the value. How many number, how many images is available. So that's why I use the size function. Okay. So size function mainly counting or computing how many images is available on this variable stored.
Only taking L8 will not work, na? In this case.
L8 is a variable name. This variable stored the full image collection. You can see it's the full image collection for the Lancet 8 surface reflectance full image collection. It is stored. So now this full image is stored in the L8. Okay. So now I simply use here the size function. So now it counting how many images is available on this L8. L8 basically the full image collection. Okay. So here I can get the more than 1 million images I can find out for the whole world between this time period, year of 2013 to 2023. Okay. This time period I can get the all of those images count in this time. So this is my large image collection. Okay. Or full image collection. In this time, this full image collection, I need to filter. Anyhow, I need to filter. So in this time, when I filter this image collection, I just need to follow the 3 factor. One factor is the specific region. Another factor is that specific image metadata or image properties. And another factor is the specific time period. Okay. Using these 3 factor, I need to filter the large number of image collection. Okay, I need to filter it one by one. Basically, it's showing the result for the whole world. But I don't need for the whole world. I need for this result only for the suppose a specific region. Suppose I need the result for suppose Dhaka city. Okay, I don't need for the whole world satellite image. I need only for the Dhaka city satellite image. Okay. So for that, here I already uploaded the Dhaka city boundary shape file. Okay, it's the Dhaka city boundary shape file. Here I already uploaded. And previous class, I show you that how we can easily import it, the shape file. Okay, just I simply import that. Okay, it will import it. Default variable name is the table. It's a table, but we can use any name. There is no problem. I simply put the name such as RY. Okay, so in this time, I got the result for the whole world. But in this time, I don't need for the whole world. I need only for the Dhaka city. Okay. So for that, take a variable. I take the new variable. Suppose filter region. Okay. In this time, this L8, you can see this L8 stored the large number of image collection for the whole world. But I don't need for the whole world. I need only for the Dhaka city. So just I simply copy the L8 and then I simply copy the L8 because this variable stored the large number of image collection. From here, I need only for those images, which image is available for the Dhaka city region. So for that, I use a function, filter bounds function. Okay. So in this time, what happened? In this time, only those images which are available for the Dhaka city region, it will be showing. Okay. So in this time, this is the L8. It's showing for the large image collection. And when I use here the filter bounds function, mainly it creates the boundary. You can see what is the argument about that filter bounds. Just you can simply copy and then paste in the documentation tab, then get the description about that. Filter bounds is the filter bounds. So it shortcut to filter a collection by intersection with geometry. Okay, in this time it's showing my full image collection, but I want to need only for this intersection with my region of interest. In this time my region of interest is Dhaka city. Okay, and Dhaka city is stored in a variable ROI. Just simply copy the ROI and paste here. Okay, so now let's check how many images is available for the Dhaka city. Just use here the print function and call the filter region, and then simply use the function size function. So now let's check how many images is available only for the Dhaka city from year of 2013 to 2023. Here we find out total 413 images. Okay, and this 413 images is available for the Dhaka city region, in intersection with Dhaka city region. Okay, so mainly in this time we filter this image collection for a specific region. Then suppose from I got the 413 images is available for my region of interest in Dhaka, but I don't need for the all of those images. I need only for those images which image will be not more than 1% cloud covered. I need only for those images which image will be not more than 1% cloud covered. So in this time I filter the image metadata or image properties. So for that, what can I do? I just take a variable, suppose filter metadata. You can use any variable name. And now from 413 images, I choose only for those images which image will be not more than 1% cloud covered. This is my condition. So these 413 images is stored in a variable. What's the variable name? Filter region. Okay, so you can see when I print the filter region and use the size function, I can got 413 images. In this time, from 413 images, I choose only for those images which image will be not more than 1% cloud cover. So for that, I simply copy the filter region variable name because I will choose it. I from this image collection 413 images, I choose only for this image which image will be not more than 1% cloud cover. Just use a function filter metadata, and you can see about the filter metadata. So mainly this function filter the image properties. Cloud cover is the image properties. Land cloud cover is the image properties. Lot of image properties we can easily get. You can see the filter metadata. In this time, filter metadata has a 3 argument: name, operator, and value. So first of all, what is the name? Name, it's mainly image properties name. Which properties you want to choose? So in this time, where I can get the image properties name? Simply go to the image data catalog, and here you can see the image properties. You can see image properties. So here you can see there are a lot of image properties. You can see the cloud cover land, all of this. In this time, I choose the cloud cover. I filter according to the cloud cover. Just simply copy the cloud cover. It's my image properties name. Just put here the name. After that, I have to use the operator. Operator we can use here the less than, greater than, equal. You can see we can use here the equals or less than, greater than, not equals, not less than, not greater than. So it's a one kind of operator. In this time, I choose only for those image which image will be not more than 1% cloud cover. So just put here the operator such as a less than. So use here the less than. Okay, then put here value. You can see what is the value. You can see after that value, I have to choose the value. Suppose 1% or 1. Okay, the value to compare you want to use in here. So you use here the 1. Okay, so now what happened in this time? From 413 images, I choose only for those images which image is the less than 1% cloud cover. So now let's check how many images are available for my region which are less than 1% cloud cover. I want to check it. So use the print function and call the filter metadata. Simply copy this variable name and paste here and use the size function. Now it's display the result. How many images are available for the less than 1% cloud cover? Here I find out the 61. Okay, this 61 image is less than 1% cloud cover for region of interest in Dhaka city. Okay, So after that, basically this, what is the time period? This time is that year of 2013 to 2023. Okay, whole time period. Whole time period, I find out total 61 images with less than 1% cloud cover. But I don't need for the whole time period. I need only for the specific time period. Summer season, rainy season, or January, February, March, or any specific time period. I need these images. So how I can do? Just I need to filter date. Okay, so take a variable. Suppose filter date, and from 61 images, I choose only for those images which image is available for suppose year of 2017 or year of 2020 or any time period. So these 61 images is stored in a variable. What's the variable name? This variable name is the filter metadata. Simply copy and paste here. Okay, then use the function filter date function. And what is the filter date? Mainly in this time, simply copy that and search here the docs tab. You can see what is the filter date. Filter date, mainly filtering the start date and end date. We have to mention about the start date and end date. In the filter date, yeah. So you can see filter date, mainly we have to choose the start and end date. Okay, and in this time I simply choose this start and end date. Suppose year of 2000, I simply put here the start date year of 2017. Suppose 1st January from year of 2017. Suppose December 31. Okay, I choose this time period. In this time I want to check how many images are available for year of 2017. So let's go. Just simply use the print function and then copy the filter date and paste here and use the size function. So now click to the run. So in this time I can get only for the 6 images available for my region of interest on this time period. Okay, so here you can see, first of all, I get the large image collection. Okay, for the full. Then this image collection I want to filter, okay, for my specific region, filtering specific properties or metadata and a specific time period. So mainly filter bounds function, it provides the where. Okay, so where you need this image for the specific location or a specific boundary, and then filter metadata, it provides the answer for the how. Okay, filter data mainly it provides the answer how. Okay, and then filter date, it provides the answer for when. Okay, so mainly where, how, and when. According to the 3 conditions, we need to filter our image collection. First of all, I can get the large number of image collection, but when I apply the where, I can get the result for 413. Then how? Less than 1% cloud cover. I can got the 61. Then when? Year of 2017, I got only for the 6 images. So this is the filtering process. Okay, and this filtering process is the same also for the Sentinel-2. Okay, I will show you the later how you can easily do that. But this filtering process is the same. Okay, so now here I can get the total 6 images. So now I want to check about their acquisition time period, all of those information about the 6 images. So for that, what can I do? Just I simply use here the print and then simply print this filter date, because filter date is stored the 6 images. Okay, so just click to the run. In this time it brings all of this information. You can see total 6 images. 6 element means the 6 images. And here you can see the feature. In this feature we can get all of those images, total 6 images, all of this information also we can get in here. You can see, and all of those images have the total 19 bands. Okay, so you can check the first image. 0 refers to the first item. First image showing the year of 2020, 18 February, 3rd December, 17th January, 2nd February, 18 February, 3rd December. In this time if you want, you can display only for the single time period image. Suppose you want to work for this image. Okay. Suppose you want to read the image, which image is the acquisition time is that year of 2017, 2nd January. You want to choose only for the single image or single time period image. So for that, how I can get the single image? For getting the single image, you have to just take a variable. Suppose I put the variable name is the image. You can use any variable name and use the function e.image. Okay. And in this time, in here, just simply copy this ID. Okay. Which time, which date you need, simply copy this ID. Suppose I simply copy this ID from here and paste. Paste. Okay. So now it's showing only for this image. Which image is the capture? Year of 2020, 2nd February. 2017, 2nd February. This time period. Okay. So now let's go about the, we add the layer about the image. So for that, just use a function map dot add layer and call this image. Okay. Basically, this is my object. I want to display the image, and this image is stored in this image variable. So now click to the run. You can see one layer will be showing, but it not focus on my center. For center focusing, I have to use here the function map dot center object. So suppose in this time image is my object. I have to focus on the image. So click to the run. In this time, it focusing on the image. You can see. Yeah. In this time, we can get the image look like that without a default visualization. It's showing look like that. In this time, how in this time it's showing as a tiles. You can see it's showing as a tiles. Okay. So in this time, you can simply add the visualization. So click on here, the layer properties, and you can use here the different types of band combination. Okay. Suppose I'm going to add here the red band, then green band, and blue band. And then also increase the reflectance stress 98% for better looking. Then apply. So in this time, it add the visualization look like that. You can see it added the satellite images as the tiles. But I need only for the specific region. I don't need for the whole tiles. I need only for these tiles for the Dhaka city. Okay. So here I already imported the Dhaka city. In this time, this is my image as a tiles. These tiles I just need to clip with my boundary shape file. Use here the clip. Okay. Then use here the ROI. It's what is the ROI? Because ROI is stored my shape file. Okay. Then click to the run. In this time I can get the result only for the Dhaka city. You see, it's just clip with my boundary area of Dhaka city boundary area clip. Okay. So now it's showing look like the default color. So I can easily add the visualization and also import the visualization in my code editor. So just click on here and set such as red, green, and blue. You can use any band combination, no problem. And then use the 98%. And then apply it. When I apply, then it will be show the image look like that. And in this time, you can see import. Okay. So in this time, this visualization is not import in my code editor. Okay. So when I run the code, then it also showing the default color. But when I just import, you can see import button. Click the import, a new line of code add in here. Okay. Just simply copy this variable name and paste after the object name. Okay. So why I paste in here? Because, okay, I paste in here map.add layer function. Okay. It's not. It will be just paste after the object name in here. Okay. So in this time, why I paste in here? Because you can see the map.add layer function. What is the second argument? You can see that what is the second argument about the map.add layer function? Map.add layer second argument is visualization parameter. You can see visualization parameter. Okay. It's a visualization parameter. It means that how I visualize my image. In this time, it's showing the satellite images. Suppose all time it is the object. After the object, we always put the visualization variable name. In this time, I already defined about the visualization. You can see red, green, and blue. Okay, I want to show this visualization. So simply copy that and paste after the object name. And my object is the image. Okay, then paste in here. So it's showing the visualization. Now this visualization is set with my code. You can see when I click to the run again, click to the run, it's showing this visualization automatically. And I also use here the suppose 10 for in this time it also increasing the zoom level. Okay. Working. Or you can also be, suppose I use here the ROI, my shape file. I focus the shape file. So ROI in this time it work. Yeah, you can see. Okay, and this visualization is also set with my code editor. Okay, because I import the visualization also in here. You can see I also import the visualization parameter in here. So this is the image for the single time period image. You can see I can get this image. So now I can easily use the image and make the different types of remote sensing analysis, such as make the NDVI map, NDWI map, or any other types of analysis we can easily do using this platform. Yeah, please. Yeah, any question?
Sir, you put that red, green, blue after that state. So can you explain these parameters little bit?
States means the reflectance value. Okay, so mainly you can see here when I use here this click on here and put here the 80% or 98%, then it will be display the range about the peak reflectance value or wavelength value. Okay, and when I put here the 98%, then it stress as a 98% and show the result for mean. It is a mean and it is a max. Okay, and then mean and max showing this reflectance value. Okay, mean and max. Otherwise, when I put here the suppose custom, then it not showing the better result. Okay, so that's why we need to increase the stress level for properly showing this image. And when I put here the 98%, then it automatically from this image choose the mean and max value and then show the result. Okay.
Hello, sir.
Yeah, please.
Sir, actually, you have imported that ROI, na?
Yeah.
Sir,
Yeah.
how to actually import that ROI or how to download that only for the particular city? Now you have taken the example of Dhaka city.
Yeah.
For example, if we want to take some other city,
Yeah.
how do we like download that ROI and how can we
Okay,
import that
okay.
value here?
So for that, you have to first of all you have to create the boundary shape file. Okay. Suppose in this time, what we can do? Just we can simply use the ArcMap software or QGIS software and then extract the only for the boundary shape file of Dhaka city. Okay. Not only for the Dhaka city. Suppose you can simply choose the India, and from this India you can easily get the all of those state level or district level boundary shape file. You can simply open this ArcMap software or QGIS software, then simply select this and then make a shape file. Okay, just I show you the process. Just a minute. I simply open my. Then it's better. So just I open the ArcGIS. Okay, I open the ArcGIS Pro software and show you the process. So basically, you have to create the specific boundary shape file or CD shape file, and from that we can easily import the shape file in the Google Earth Engine platform and work with that. Same approach all time. Okay, just a minute.
And my one more question is,
Yeah, please.
you have added now, sir, this Landsat data, image collection.
Yeah.
So this, can you just tell me once again, how did you?
So basically in this time here I can get total 6 images. Okay, sometime you have to need only for the single date images. Okay, suppose you want to work only for the single date images.
No, not this.
Yeah.
Not this. Starting you like imported this Landsat data. Na? Here in the next tab, Landsat data you imported, and there were like thousands of images which you got here. Na?
Yeah.
So yeah, 1 6. So
Yeah.
this value, how did you like add to this? Can you just tell me that?
Okay, so this value is for the whole world. Okay, whole
Yeah.
world for the whole time period. Basically, year of 2013 to 2023. And for the whole world, how many tiles is available for the Lancet
Yeah.
A?
This, how did
It's
you get
showing.
this, sir?
Okay,
USGS.
so for
Yeah,
that,
this one.
how basically in this time you can see, I just simply copy this image collection. Okay, I simply import this, simply copy. Basically, it's a unique ID, and this unique ID is stored the full image collection, of Lancet. Okay, I simply copy and paste here. Okay, and then give a
Okay.
variable name LA. So now this
Mm-hmm.
variable is stored the full image collection. So now I want to check how much images is available. So for that, print LA and use the size
Yeah.
function. This size function determine or counting or computing how much image is available.
Yeah.
Okay,
Okay. Okay. Sir,
then
this
we can, yeah,
this Landsat data. So
yeah.
how can you tell that like the data is available from this date to this date, or will it be saved automatically in the Google Earth Engine data set itself?
Yeah, it automatically updating. Okay, you can see current date, we can get the data year of
Can you show
2023
for
08.
any another example, sir? Instead of Landsat 8, can you show it for Landsat 7
You can
or
also try
any?
about that first, then I also check. If face any problem, then let me know, no problem.
Okay. Okay. Yeah.
So basically filtering process is the same you try to do for using the, and I also put the assignment for the 2 days after completing that class for the Lancet 7, Lancet 9. So you try to do that, because in this time it's a very easy way, you can easily do that same approach, and
So
then
we
face
just have to
problem.
go to view all data sets.
Yeah,
Okay.
yes, yes.
Yes, sir.
Okay, and make the shape file. You can simply click, open this boundary shape file and just make the boundary shape file, simple ArcGIS or basic GIS. You can simply search on YouTube, lot of video you can get from here for how you can easily make the boundary shape file. Okay, or extract the boundary shape file, lot of video is available for YouTube. Yeah, so now I can get the result look like that for the true color composite. Okay, for this only for the single time period image. Okay, so as well as if you want, in this time I show you only for the single date image how you can easily create. Sometime you have also need to create the different types of composite, such as median composite, mosaic composite, main composite. So now I show you that how we can easily create the composite. Mainly it's showing the how I can make the different types of suppose median composite. Median composite, mainly it take the median pixel value or middle pixel value and make this composite. Okay, suppose in this time here I got the total 6 images. When I create the median composite, it take the all of this middle pixel value and make a one image. It's called the median composite image. Okay, so let's go about the, and this is the process for showing the result for the single date image. So now it is stored at the single date image. Okay, so now this image I can use the lot of remote sensing analysis. Okay, so in this time how I create the median composite. Okay, for creating the median composite, mainly take the middle pixel value from total 6 images and make this composite. So take a variable, suppose I put the variable name is the suppose final image, and then call the filter date because it is stored total 6 images, and from these 6 images I need to create the median composite. Just use here the median. Okay, so now it create the median composite create from total 6 images middle pixel value of these images. So now display the result, map.add layer, and also this after creating the median composite we have also need to clip with our boundary shape file ROI, then simply copy the final image. Okay, then click the run. Now it create the median composite. You can see, so first time it's showing the this type of default color showing this type of, but when I increase the reflectance mean and max value and also set the color band combination, you can get the better view. Suppose I put here the suppose red, then put here the green, and also put here the suppose blue, and increase range 98%. Then you can it automatically choose the mean and max value, then apply it. So now it create the median composite. So in this time it's not a single image. it's created from total 6 images middle pixel value. So it's called the median composite. Okay, man, median composite need, suppose you want to work for the whole country boundary of Bangladesh. Suppose you need the Landsat image for the whole country boundary of Bangladesh. For the Bangladesh or any big region is not possible. One tiles is not fully cover your region. Okay, suppose you can see you want to need for the satellite image for the whole country boundary of Bangladesh or whole country boundary of India. So then one tiles is not cover your region. Then we have to apply the median. Okay, so all of those tiles we create the middle pixel value and make the composite for the whole country boundary of Bangladesh or any other big region. Okay, then this median composite is also used. Okay, in this time this image showing for the median composite, and it's the, what is the time period about that, 2070 1st January 2000 December 31. Okay, whole time period all of those images, I create the median composite and display this satellite image in here. So whole time period I can get only for the 6 images. So this median image created from the 6 images and now display the result in here. Okay, so it's a process for creating the median composite. Sometimes median composite mainly need when you want to work for the big region, because one tiles is not complete to fill up the full region, such as Bangladesh or India is not possible. So that's why then we have to apply the median. Okay, so this is the process about that single image as well as also create the median composite. So in this time, okay, so I also imported this visualization. So just you can see import button in here, just import and then copy this variable name. You can see just simply copy this variable name, and this variable I just simply paste after the object name. So this is my object and put the object name in here. Okay, so in this time, suppose you can see the map.addLayer function again. I simply dock step and you can see map.addLayer. So what is the third argument? One argument is the object, then visualization parameter, and then name. What is the name? Name about the layer name. In this time you can see it's showing the layer 1, but I can put the layer name anything I can put in here. So just put the layer name. Suppose I put the layer name, suppose true color composite. This time what happen, you can see it's showing the true color composite. Okay, so this type of argument we have to put sequentially, one by one. Suppose put here the object, then put here the visualization parameter, then put here the layer name. Okay, step by step you have to put. Suppose you did not put the visualization parameter and then you put here the layer name, then it will be not work. It's showing the, you can see error. Okay, so you have to put all of those things one step by step, one by one step. Otherwise it will be showing the error. Or if you want, you can also use here the blank. Suppose put here the this curly bracket, put here. So now it's working as a blank or without any visualization. So now click to the run. In this time we can get the result. You can see it will work. Okay, so we have to put the sequentially one by one. So here I already defined the visualization parameter. Just simply copy and then paste here and click to the run. So now it's add with my image and I can get the result with visualization for the true color composite. Okay, so now how I can download these satellite images from here. Okay, so for downloading the satellite images, okay, before that I also talked another thing is that here you can see here I take the variable for every single function. For the filter bounce function I take a variable. Filter metadata function I also take a new variable. Filter date function I also take a new variable. Okay, median I also take the new variable. Okay, but if you want, you can take only for the one variable, and in this variable you can put all of those argument one by one. Okay, so basically this is the first time for the understanding yourself, that's why I want to just put all of those function and individual variable. But it also has the another shortcut keyword is that you can simply put only for the one variable, and in this variable you can add all of those function one by one. So let's go how it will work. I simply select all of those things for commenting. In this time I comment all of those things. In this time it not work. Just simply select and press Ctrl and forward slash, then it will comment. Okay, so in this time I take only for the one variable. Okay, and under this variable I put all of those function. So take a variable, suppose image. Okay, then call the L8. It's my full image collection. Okay, L8 filter bounds with my region of interest ROI. After that, spaces doesn't matter. You can use any here. There's no problem. If you want, you can write in here. There is no problem. Or also you can write in here. There's no problem. Okay. So basically, JavaScript programming is totally space, not need for any types of 4 space or 3 space. It's not need. Space is mainly matter in the Python programming. Okay. So just I put here the suppose filter. Suppose filter metadata. Metadata. And put here this property such as cloud cover. Operator is the less than, set the value for 1. After that, I put here the another thing is that filter date function. Okay, and put here the start date such as year of 2000, suppose 2017 1st January from year of 2017 December 31. Okay, so in this time you can see it will be done. So first of all, it's my question about the where. Then second is that how. Another is that when. Okay, so in this time it's my image collection. It create the image collection. Okay, it create the image collection. But when I make the median composite, suppose I just put here the median function, use here the median function. So now after applying the median, it's not a image collection. It's just work as a single image. Okay, so without median, it's the image collection. So you can see here in this time I simply print that. So print the image. Just use here the size function and click to the run. In this tab, it is an image collection. How many image collection in here? 6 images. So for my region of interest, according to the less than 1% cloud cover, in year of 2017, I can get 6 images. So it's an image collection. But when I put here the median function, then it's not an image collection. In this time, we can get the wrong. In this time, it's showing, you can see, image is not a function. Okay, because only for the image collection, size function work. Okay, but when I apply the median function, then this image variable is not a collection. It turn into the median or single image collection. Okay, size function is only work for the collection. But when I apply the median, then it will be not a collection. It just create the median composite from this collection. Okay, so now it will be, I simply click with my shapefile. So click with RY and now display the result. So now it display the result. So use add the map.add layer such as image and click to the run. In this time it display the result without visualization. You can see without I can get the result. So for that I can simply copy, and I already imported the visualization. So simply copy that from here and paste. And now also put the layer name, suppose true color. Then click to the run. In this step, it's showing the image about this region. So not only for that, suppose in this time you have to need the image for the other region. Just simply import your own shapefile, which region you want to need. Suppose I simply choose another region. Yes, please. Any question?
Sir,
Yeah, please.
our region falls between two parts, right? Means some part of region is falling one tile and other part is falling in another tile. And these time difference is different for the passes of these satellite at different times. So when we apply the time filter, so will it work for both, or it will work for only one part?
Yes. Okay. So basically in this time we filtering this time period. Okay. In this time period we filter and got the total 6 images. Okay. From these 6 images we just make the median composite. Okay, then it will be work as a single image. And this single image, what is the time about that? It will be generate all of those images which is available for the year of 2017. All of those images. Okay.
Sir, my question was that if our region falls into path of satellite, means one satellite passes from one region, part of region on different dates, and some part of region covers by satellite on different dates, side by side path. So if one path falls 6 images between this date and another path falls two or three images, then it will create some difference or it will work.
Okay, so basically in this time we are not filtering using the path. Okay, in this time we are not considered about the path or a specific path. We are not filtering about that. We just filtering our when, how, and where. Okay, but for it also possible to filtering the image using the path. So it's another way for filtering the specific image path about that. Okay, so but in this time we are just focused only for that specific region, a specific time period, and a specific condition for the filtering image properties. But using the path is also possible. Suppose you want to put here the path number and filter that, it also possible to that. Okay, so now suppose I simply put this, suppose I put this Delhi study area, simply put in here, and then simply change my region of interest, and then put this name as the ROI. So now I can get the result for this Delhi region. Okay, I also need to focus, so use here the map dot center object is that ROI. Okay, suppose zoom level is the 10. Click to run. Now display the result, you can see we can get the result. So in this time, when I send you this code, you can easily modify for your own region. You can also modify this time period, okay, and get the result look like that.
Sir, um,
Yes, please.
sir, actually, do you have to save all the ROI files in Google Earth Engine? Then only you can import.
No, I can individually import it, all of those ROI. Okay, so basically it's not a ROI. You can use any name. Okay, so basically I import all of the shape file in the asset tab. Okay, so which I need. And same approach. Suppose what can I do? I just simply ArcMap software just extract the data only for this Delhi study area.
No.
Okay,
How
and
did you
import
get
this shape file.
this assets in this list?
Okay, so I import that. So I simply click on here and then go to my source file. Okay, then simply select that my source file SSP, SSPRG, and DVF file.
Okay.
Then it will be imported. Yeah. So this is our study we can get. So now we can easily use this code for any region which you want to need the satellite image less than 1% or any time period. You can simply choose it and get the result. Okay. So now I show you that how we can easily export this satellite image. Before that, I also try to discuss about the another data set, then combine the two same things for the exporting for the another data set. Okay, so let's go. So this is the process for filtering and visualizing the satellite images, mainly Landsat. Okay, using this method or using this process, you can also try to filter Landsat 9, Landsat 7, or Landsat 5. You try to filter for your specific region, a specific time period. Okay, and when you filter, definitely you can get the some error. This error is that it can be gap filling error or scan line error. So this type of problem we can face when you want to work with the Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So basically Landsat 8 and Landsat 9 is very work well. Mainly Landsat 5 and Landsat 7, we can face the problem for the different types of problem. Scan line error or also get the different types of unnecessary pixel value. Okay, but it has also another way for filtering. So first of all, you try for Landsat 7 and Landsat 5, but not for all of those regions. Some region we can get the some problem such as scan line error or gap filling error. This type of error it's available for the Landsat 7 and Landsat 5 and 4. Okay, so according to the same approach, you try to for the Landsat 7 all of those image collection. Okay, try to filter and visualize this way. Yeah. Yes, please.
Sir,
Yeah.
sorry, is it possible to filter a particular pixel, sir, particular location?
What the pixel?
So particular location, I want a reflectance value. Location, lat
Okay.
long based location,
Yeah.
I
Yeah.
want a reflectance value.
Yeah. So for that, you can use the inspector tab and click on this specific region. Then it will also showing this for the specific coordinate. What is the spectral value we can get?
No,
Okay.
no, I want to give, I will give the lat long one. So
Yeah,
I want
it
a
also possible.
value.
Yeah, possible. Suppose in this time we can simply put my some lat long about the as a point. So now this point you want to extract the band pixel value. Okay, it also possible to that. Yeah, it also possible. And I already create the video about that in my YouTube channel. You also try to check about that. And if you don't know that, then also knock me later. I also send you the process how we can easily extract the band pixel value from the point different point
Sure, sir.
collection. Yes, please.
Sir, now you have like filtered 6 images. For example, when that tile, if at all, if that particular tile is not covering the entire region for the ROI which we have selected, so
Then we
how
have to
can
use
we
the median composite.
uh, can you
Okay,
please
we combine all of those images. Okay, suppose you want to make the large image collection for the India or Bangladesh, you have to need this satellite images. One tile is not covered, two tiles is not covered, so there are the lot of tiles we need. So that's why we have to create the median composite. Okay, we have to create the median composite, then it will be combined. It take all of those middle pixel value and make this composite. Okay, so
okay,
you also
okay.
try to do for the whole India boundary, for the Landsat, for you can just make the composite for the whole India country boundary using the Landsat image. Okay,
Yes,
then
sir.
you can get the idea how we can easily work with the median. Yeah,
Yeah.
yeah. So any question? Okay, okay. Okay, so if there is no question, then I simply go to the another data set, such as in this time I work with the Modi's data set. So here we can get the different types of Modi's product, daily product or the monthly product, or we also get the different types of data set you can see. In this time, I show you only for the one product. You can just apply the same process for any other product. Okay, so all of those things will be same for visualizing or creating the map for the Modis. Here you can see the lot of data set for the Modis LST data set for 8-day global. Also you can see Modis gross primary productivity 8-day global. Also you can see Modis evapotranspiration data set 8-day global. Modis trap visitation index is 16-day global. Physician index is 16 the global. Okay, there is a lot of data set is available, and all of those data set is the same approach when you want to filtering, visualizing, or making the chart. All of those things will be same. So in this time, when I show you only for the one data set, suppose I show you the vegetation indices, using the same approach, you can also apply for the trap vegetation indices, the another data set. Also, you can see the evapotranspiration data set, net evapotranspiration data set, also LST data set, gross primary productivity data set. All of those things will be same. Okay, just I show you only one, and other of data set you try to for making the map. Okay, and the same approach all time. So let's go. How we can easily create the map using the Modis. So in this time, suppose I want to choose a data set. Suppose I want to make this map using this data set. Vegetation index is 16 global, 250 meter resolution. This data set I want to use. So basically this data set called the ready-made data set. Okay, this type of data set is already created, such as you can see. Already created means that this data set provide you directly band NDVI. You can see it create the band about the NDVI. So now when I use this image collection, I can easily make the NDVI map or EVI map. Okay, I can easily create because it is a totally ready-made data set. But you can see when I use here the Landsat image, this type of Landsat image, it's not a ready-made. It's not a ready-made. So for that, here I apply the equation such as near minus rate divided by near plus rate for vegetation. But in this time, this data set is the ready-made. It ready-made give me the NDVI band. So that's why I don't need to create any types of equation or other things. Just I simply import the data set and work with that. Okay, but when I use this type of images, then I have to apply the equation for NDVI and then make the NDVI map. But in this time, I don't need, because I can use the ready-made data set. Okay, so how I can use that? First of all, I need to import that. For importing, same approach. Just simply copy this snippet and paste in the code editor. Okay. Then give a variable name. Suppose I put the variable name is that any name. Suppose put the name is the modis. Okay. And this image collection have a two bands. One is NDVI, another one is EVI. I want to work with the NDVI. Okay, I want to work with the NDVI. So that's why I need to select the NDVI. Just use a select function. Use the select function and put the band name NDVI, because I want to work for the NDVI, not EVI, because this image collection has a two band. From this two band, I just select only for the one band NDVI. Okay. So now this image collection, you can see the time period is that year of 2002, 2023, 0813. This is my time period. I don't need for the whole time period. I need only for the one single year. Suppose I need this time period for a specific time period. So for that, I use a function, filter date function. Okay. And put here the time period. Start date such as year of 2020. Suppose 1st January from 2020, December 31. Okay. So now you can see here, I simply filter. I select my specific band from this image collection and also filter the specific time period. Okay. So now let's check how many images I can got in here for the whole world. Just use here the print function and call the modis, because I stored all of those things in the modis, and use here the size function, size. So now let's check. It's showing the result about that, how many images I can get. Only for the 1 year, I can get the 23. Because it is a 16-day interval. So 16-day interval, suppose 16 into 23, we can get almost 1 year. Okay, 365 or 1 year. So in this time, this data set is that 16-day global. You can see 16-day. Okay, for the 16-day global, that's why for the 1 year, I got only for the 23 images. Because what is the time interval? 16-day. Okay, if you want to check about that, suppose you use the print function and call the modis, just you can check about the 23 image acquisition time. You can see the time from the feature. Okay. You can see 1st January, 17th January, 2nd February, 18th February. So it's showing the result. Time interval is a 16-day. Okay. For the 16-day, we can get the 23 images for 1 year, because our interval is the 16-day. Okay. So this is my image collection. Here I can got my image collection. Okay. So now this image collection, you can see I can get the 1 year for total 23 images. And this total 23 images is not captured at the same time. It captured the different time. 1st January, 17th January, 2nd February, for the different time. In this time, this image collection, I need to reduce. Okay, I need to reduce this image collection. In Google Earth Engine platform, reduce is a statistical function. Okay, I need to reduce it for displaying the result. Okay, so in this time, we are using here the average for reducing, or median for reducing, or standard deviation for reducing. So lot of statistical way we can use here the reduce. Suppose in this time, I just created the average pixel NDVI from total 23 images. From total 23 images, I just create the average pixel value of NDVI. I reduce it using average or mean. So let's go about that, how I can do that. Take a variable, suppose average NDVI. Okay, and this average NDVI create from total 23 images. So, and this 23 images is stored in a variable. What is the variable? Modis. Copy that and paste here. In this time, this modis, I need to reduce it. So how I can reduce? In this time, from total 23 images, I just need to create the average pixel value. Okay. If you want, you can also create the maximum pixel value or minimum pixel value. I want to create the average. So just use here ee dot reducer dot mean. Okay. it's created the average pixel value and reduce the single image. In this time, average NDVI it create only for the single image, and this image come from total 23 images average pixel result. So now let's display the result. So use add the map.add layer and simply copy that. In this time, we can generate the whole world NDVI map year of 2020. So it display the result for the whole world NDVI map. In this time, we can see it showing as a gray scale color because I did not add any visualization. So that's why it's showing as a gray scale. So now I can easily add their default color. You can see all of those code have also some demo code. You can see they also use some demo code. So this is the demo code about this code. Simply copy that. Okay, in this demo code, you can see I just simply paste in here that it's a visualization code. So in this visualization, they are put here you can see the result for the mean start from the 0 pixel and max up to 8000 pixel and use the different types of color plated. Okay, I simply copy this variable name from here and then paste and click to the run. In this time, we can get the visualization of NDVI map and we can easily identify where is the dense vegetation, where is the low vegetation. Okay, you can see it's showing the whole world NDVI map year of 2020. Okay, you can see the result about that. And suppose in this time you don't need for the whole world, you need only for the specific region. So what you can do, you can simply export your shape file. Suppose I simply export the shape file of suppose lake chart. I simply import the lake chart shape file. Okay, I already import the shape file and put the name such as a RY. So you have the RY. Okay, so now what can I do? Average NDVI, I create the average pixel value of NDVI for the whole world. From this whole world, I just clip it with my region of interest, ROI. So now I can get the result only for this, my ROI, but it not focus. In this time, I simply use a function map dot center object, and my object is the ROI. Suppose zoom level is a 10, click to the run. In this time, it's center focusing on the lake of chart, and we can get the NDVI map. Okay, so you can easily import your own shape file, own boundary shape file, and you can easily create this type of map. As well as we can also get the another. Okay, so previous class also discussed about the US DUS data set. So this data set we can also get also you can use it. Suppose I simply search here US DUS data set, and basically it provides the all of those international country boundary polygon. Simply import that, and now I simply I remove that, it's not needed. Suppose in this time I imported the all of those country boundary polygon. So from here I just need to filter and choose my specific country. Take a variable, suppose ROI, and call the table and use the filter. And previous class I discussed about that. So filter equal what's equal what, suppose country name. I put the country name, suppose Bangladesh. Okay, so now click to the run. In this time I can get the result for whole country boundary of Bangladesh NDVI map year of 2020. Okay, we can get the result look like that. As well as suppose I choose the result for suppose Saudi Arabia. Click to the run. In this time I can get the result for the Saudi Arabia. You can see very less vegetation. We can find out some, it is a cropland. The full NDVI map of Saudi Arabia. Not only for the any country, just put the country name, because I import the data set for the all of those country boundary polygons. Suppose I put this name such as Australia. So now it's showing the result for Australia NDVI map. You can see the Australian NDVI map. Okay, as well as suppose I put the country name such as Japan. So any country boundary we can easily get from here and make this NDVI map for that. Okay. Such as India. Okay, so anyone in question you can ask me.
Sir, hello.
Yeah, please.
Sir, we are working on ocean. So we want a specific region, means not a shapefile based. So
Yeah.
suppose lat long based, so particular area we want square meters of area. So how to give the ROI in a particular boundary of particular location? Any idea, sir?
Okay, so let you have only for the lat long. Yeah. So first
Not
of all,
lat long,
this,
sir.
yeah.
Okay,
So
one
this lat
square.
long you have to convert into polygon or point using the ArcMap software or QGIS software, and then import it. This lat long, as well as you can also have the lat long. You can also import as a CSV file. Suppose you can say asset tab. In this asset tab, has the another option is that CSV file. Okay. Suppose you have the two column lat and also longitude and latitude two column. So you can simply put the all of those point in here. So go to your source file and select the CSV file. And after that, you have also need to mention the another thing. This thing is that simply go to here. You can see your X column name. Okay, in your Excel file, which name you can put? Just simply put the name in here. Suppose longitude, you can put here the long, LON, long. Then put here the LON, long. Or Y, lat, LAT, lat. You can put the your Excel file, which name you can put, just use the same name and then upload it. Then it will be work as a shape file or point shape file for your specific coordinate.
Yes.
Okay.
Yes.
As well as you have the polygon or let or all of those suppose is lot of letter long, not for the point as a polygon, then you have to convert it using the ArcMap software or QGIS software. Just convert it as a polygon and then work with in here. Okay. Or if you want, you can also draw your own region. Suppose I can simply draw my shape file also in here. Suppose you can see the draw polygon tool, all tool. Suppose I need this NDVI map for this region. Just I simply draw my region of interest. Suppose I simply draw it, just rectangle or polygon, anyone you can take, and then simply select your region. Suppose this is my region. Okay, and I simply choose it as a geometry. I simply put the name such as a ROI. Okay, and this ROI simply comment that in this time it not work. In this time this ROI is work. So now click to the run. In this time it's showing the result only for this boundary and create the NDVI map. Okay, so now I can get the result only for this region. Okay. You can also draw our region of interest and show the result. Okay, so this is the process for creating the NDVI map. But this NDVI map has a problem. This problem is that you can see here, and I simply show you that suppose NDVI range always +1 to -1. Okay, so in this time NDVI values range from +1 to -1, and different types of pixel value has a different types of information, such as you can see the 0.1 or less we can identify as a barren rock, sand or snow. Okay, or very low NDVI values identify sparse vegetation. Okay, shrub. Okay, so you also try to read about that, then you can also get about the different types of idea which pixel value range, which vegetation you can see NDVI values range from +1 to -1. And also you can see the barren rock, sand or snow usually show very low NDVI values, 0.1 or less. 0.1 or less, it's saying the barren rock, sand or snow. Sparse vegetation such as the shrub and grassland or sensing the crop, you can use at the NDVI value 0.2, 0.5. Okay, and high NDVI value approximately 0.6 to 0.9. Okay, it's showing the high NDVI value such as dense vegetation or also tropical forest or crop at the peak growth stage. We can get the high NDVI value. When the crop at their peak growth stage, we can also get the high NDVI value, approximately 0.6 to 0.9. Okay. So in this time, you can see the value. Suppose instead of tab and click on here, I can get the result look like that. You can see. I can get the value for this specific coordinate 4,289. I click on here. In this time, it's not scaling. Okay. So that's why you can get the result look like that. But this NDVI pixel value range all time -1 to +1. Okay. So in this time, anyhow, I need to rescaling this all of those data and show the result. Okay, so let's go about that, how I can rescaling the data. For rescaling the data, yeah, please. Anyone, any question? Yeah.
Sir, we used here average function, means, and in Landsat we use median function. So
What?
we cannot use that median function here also.
In this time, we reduce using the average result. You can see mean. Okay. So if you want, you can take the middle pixel value of NDVI, no problem. You can take the average pixel value, no problem. You can get the maximum pixel value of NDVI. Okay. So in this time, we take the average result of NDVI. Okay.
Suppose we want to get the median. So same function we can apply that we applied in Landsat.
Okay. Then it take the middle pixel value of NDVI from 23 images.
Yeah, it's clear, but in same way we can write the dot median that it will work for some different way we have to write.
Yeah, same thing. In this time, we calculated the average NDVI. Average NDVI. Okay. So that's why we are using at the mean.
Sir, it is clear, but I am asking that if I want median, then the same way I have to write that dot median in the same way we write Landsat or in different way we have to write.
Okay, I don't understand actually about the question.
Please, sir, I am asking, in Landsat data, we wrote dot median function in code, you know? But if suppose I want median pixel value, so I write the dot median function only, or in some different way dot dot
Okay, I understand.
dot
Yeah.
median.
So in this time, you can talk about the reducer dot mean. If you want, in this time, if you want, you can use it at the directly. You can use it at the mean function also. Okay, same approach. Or suppose you want to use it at the median function, same approach. But is the in this time we are just another way we can write. So for that we are using at the first of all, and this is the proper way. Suppose reduce is an statistical function, and after that I need to define how I can reduce. Okay, so it's a proper way for write that. But if you want, you can also use it directly. You can use it at the mean or median. It also work. There is no problem. Okay, it's also work. For the same task, we can get the same. Okay, but in this time for the reduce, it is a new function, so that's why I have to write in here. But if you want, you can write only for the mean, only for the median, or only for the write the suppose you use at the max. Then it also work. Okay, but it's a proper way. Just use the reduce. Then how I can reduce? In this time I reduce using the mean or average pixel value, and then result. Okay. Okay, so I hope you can got this point. So in this time you can see here, I can get the NDVI value, but this NDVI value is not scaled. It's showing the result look like that, 373. But this result will be -1 to +1. So in this time, how I can reproject it, this scale value? For reprojected the scale value, they also provide the scale. You can see in this data set, they also provide the scale. This is the scale 0.01, 0.001 for the scale. In this time, this scale value I want to use, and then this scale value just need to multiply. This scale value I need to multiply total 23 images. Okay, so here you can see for first I print that. So print the modis, use that the size function. In this time I can get the total 23 images.